We are continuing verifying trig identities for this lesson. You are again going to want your trig identities page out. I tried to make sure I put a copy of it on Canvas as well. All right, so just more practice. No new tricks for you really. It's just kind of practicing some more and introducing some more tricks that were on the list that I gave you guys in the previous lesson because we didn't use a lot of them, so just kind of building that repertoire up. All right, so this one, we are going to verify that secant of theta minus cosine of theta, all divided by tangent of theta, is equal to sine of theta. Step one is always to copy. Whichever side you are starting with should be the more complicated side. Generally, when you are choosing, make sure you copy that side down. So secant theta minus cosine theta, all divided by tangent theta. So now we want to step back and we want to take a look. I see a couple of options to start. Option number one, we can throw some identities at this. We have three different trig functions. It's not very easy to operate with three different trig functions. So getting it all in terms of sine and cosine, that was one of the trig tricks I gave you in the previous lesson. Getting everything in terms of sine and cosine is frequently a good way to start, so we could do that. Option number two, I see a fraction here that has a subtraction in the numerator. We can split this fraction into two parts. I think I'm going to go with option number one. I'm going to make some changes and get everything with sine and cosine. Now, I mentioned in the previous lesson, I don't want you guys making big jumps. Don't do too many things at once. But the one thing that I will allow, and I'll write it down so you can see it. So allowed, if you want to use multiple identities in sections 1 and 2, I'll let you do that. So if you're just changing everything to sine and cosine and you want to throw a couple reciprocal identities down and you want to throw a quotient identity down as well, make all of those changes all at once. That's fine. I don't want you doing like 3-4 different identities and do a reciprocal and do a quotient and do a Pythagorean, and it gets too much to handle. But if the purpose is I want sines and cosines everywhere, you can throw down multiple identities as long as it's reciprocal and quotient. I will let you do that. So I'm going to be using 1D here to change the secant and 2A to change the tangent. I'm going to leave the cosine alone, but again, as long as it's sections 1 and 2 and you're just switching to sines and cosines, go for it. Change more than one at the same time. So the secant changes into a 1 over cosine. The cosine in the back stays. And then all divided by tangent is sine over cosine. So at this juncture, we kind of have, again, two options. Option number one, which is how I could have started in the first place, we can split this fraction. So splitting the fraction is perfectly fine. Option number two, I see a fraction in the bottom. If you have a fraction in the bottom all by itself, you can flip it up and multiply. Okay? So I think I'm going to take that option instead of splitting this fraction. And again, splitting the fraction is perfectly fine. But instead of splitting the fraction, I am going to take this fraction in the bottom and I'm going to flip him up and multiply. You do need to be a little careful when you do that, and that's why I'm taking this option rather than splitting the fraction. Because when you take this option, the entire numerator, notice my parentheses, has to be multiplied by that fraction flipped over. So the entire numerator gets multiplied by that fraction that's flipped up. we are going to distribute. Okay, so super important when you do this, make sure that you distribute. If you split it into two fractions first and then flip the fraction up in both of the fractions, you're going to wind up with the same result that I'm about to get. But if you flip it up without splitting it, you need to distribute. All right, so let me scooch a little bit. So now we're going to distribute. And then just so I don't have to write all of this down, when you do 1 over cosine times cosine over sine, when you multiply fractions, yes, you can cancel. So you get 1 over sine minus, and then cosine, which is really a cosine over 1, times cosine over sine. This time the cosines don't cancel. The cosines multiply. Cosine theta times cosine theta is cosine squared theta. And then the bottom 1 times sine is sine. So when you multiply fractions, multiply the tops, multiply the bottoms. If you have something in the top matching something in the bottom, like what happened in the first one, then you can cancel. So now what I see is I see that these two fractions already have a common denominator. And so I'm going to combine them. I get 1 minus cosine squared theta, all divided by sine theta. And then here's that little warm and fuzzy part. Okay, there's my little warm and fuzzy. Oop, I gotta make him glow. He's gotta glow a little bit. Okay, warm and fuzzy part, 1 minus cosine squared theta, that is 3a, my favorite identity. 1 minus cosine squared theta is sine squared theta. So that's the first time we've used an identity in a little while, 3a. Make sure you bring that denominator along. And then sine squared theta in the top and a sine of theta in the bottom. You can cancel one of them, and we get sine of theta, which was the goal on the other side. Smiley face, here we come. There he is. Okay, so this one was definitely longer, much longer than what we did yesterday. But I really didn't use any tricks that I didn't outline yesterday. So let's just kind of step through one part at a time. So step 1, I changed to sines and cosines. I gave you guys that trick yesterday. That's my first trig trick. Change everything to sines and cosines. And then, like, we did algebra for a while. We had a fraction in the bottom. I flipped it up and I multiplied it, which legal fraction moves. Like when you flip a fraction up like that and multiply, you got to multiply by the entire numerator. So we distributed. We got to here. After we got there, oh, common denominator, put them back together. 1 minus cosine squared, up there's another identity, changes to sine squared, and then things cancel. So it's just going to take some repetition, kind of familiarizing yourself with what identities are helpful, kind of getting used to and remembering legal moves algebraically, like flipping this fraction up and making sure to use parentheses, canceling as you distribute, stuff like that. But it's just going to take some repetition to get there. So there really wasn't anything like super duper hard here. I kind of followed my nose and I was telling you guys multiple options along the way. But you pick something, you try it, you see if you get anywhere. And if you don't get anywhere, start over and try something else. Like it's just going to take practice. Next one. So cosine theta plus tangent theta times sine of theta. We want to verify that that equals secant theta. So I would definitely suggest, if you're feeling independent, please, at any point during this process, pause the video, try these by yourself, because you're going to learn more. Whoops, my mirroring quit. You're going to learn more by trying them on your own and kind of seeing what works and what doesn't, and try something out and whatever, and then go back and look and see what I did. But you're going to learn more if you kind of do like a trial and error approach once you kind of develop your bag of tricks. And I would suggest, like, if you were writing down my list of tricks yesterday, or open up my notes and have the tricks in front of you. Like, okay, she suggested common denominator with fractions. She suggested distributing with parentheses. Like, try those things and see if it gets you anywhere. If you get something that looks harder than what you started with, well, maybe you're not making progress. Start over, try something else. So trial and error approach, and you guys doing a lot of these independently, that's how you're going to get better at them. All right. This one, copy first. Cosine theta plus tangent theta times sine theta. So right off the bat, I'm seeing 3 trig functions. I don't like 3 trig functions. I prefer 2. I don't see any like factoring or simplifying. I don't see any algebra stuff happening here. So I think I'm just going to take the identities route. I'm going to use 2a to change tangent. Cosine theta in the front stays. Tangent gets replaced with sine over cosine. Please, 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 even though I don't say it out loud, please make sure that you put those thetas with the sine and the cosine. No little naked trig functions flying around. Like, everybody needs to have their theta on. All right, and then sine theta back here. In the previous lesson I mentioned, multiplication always trumps addition. So don't be like canceling cosines. Those have an addition between them. That doesn't work. So the stuff in the back is what we need to worry about first. Sine theta over cosine theta times, that guy back there is a sine theta over 1. The sines don't cancel, but they do combine. So I'm going to multiply those 2 fractions together. The cosine theta in the front is just coming along for the ride at the moment. Putting those fractions together, you get sine squared theta over cosine theta. So, options. Option number 1, the option that I'm going to take is I've really got 2 fractions sitting here. I'm going to get a common denominator. Option number 2, now we have a sine squared sitting in that numerator. Option number 2, you could go and use identity 3a and replace sine squared theta with 1 minus cosine squared theta. So again, there's multiple options. I can't, for time and space sake, so I'm not sitting here just recording video of every possible option. I can't do every possible option. If you write a solution up and you're like, I'm not sure if I did this right, take a picture and send it to me. And I can tell you if you did it right or if you did illegal stuff. So I can't sit here and do every option. I have to pick a route. And again, there's frequently more than one way to get there. So I'm taking the common denominator route. My common denominator, 1 times cosine theta, is cosine theta. The first fraction to get to that common denominator, first fraction top and bottom, gets multiplied by cosine theta. So when we do that, we get a cosine squared theta in the top. Second fraction, denominator doesn't change, so numerator doesn't change. And there's that pretty little thing sitting there again. Oh, my little warm and fuzzy's coming back out. There he is. I'll make him all fuzzy. There's the fuzzy. Okay, my little warm and fuzzy. There he is. Cosine squared plus sine squared. Oh, look at that. It's all good. It's beautiful. 3a. The numerator is equal to 1. So then we're at 1 over cosine of theta. That looks pretty darn simplified. The goal is to get to secant, and lucky for us, 1C, 1D, it doesn't matter at all which one you write down. This is equal to secant of theta. Next up, so just lots of examples. The more we see, the more we practice, the better we get. So copying down, left-hand side, cosine theta, parentheses, secant theta minus cosine theta. So options here. We've already got a couple of cosines. You can change secant into 1 over cosine using a reciprocal identity. I think that would be a good start. Other option, I see some parentheses and a guy sitting out front. Distributing would be the other good first option. We're actually, no matter which one you start with, going to execute both of those things. So I think I'm just going to start with the identity. So let's use 1D. Cosine theta in front hangs out. Secant changes. Cosine theta in the back hangs out. So just make that swap from secant to 1 over cosine, and now distribute. So you could have distributed first and then use the identity. We're going to land at the same place. Cosine theta times 1 over cosine theta in the front is 1. Cosine theta times negative cosine theta in the back is negative cosine squared theta. Make sure you are multiplying those, not adding them. You don't want to get like a minus 0 in the back. You're multiplying those. And our goal is to get to sine squared of theta. Lucky for us, 3a says that 1 minus cosine squared of theta is in fact equal to sine squared of theta. Getting a little bit more interesting here. I get tired of drawing the same smileys. So, good to go there. The next one has a fraction. I'm going to start with the left-hand side, so I'm going to copy it down. Sine theta plus tangent theta, all divided by sine theta. So options here, you can change tangent of theta into sine of theta over cosine of theta. Oh, sorry. You can also take this fraction and split it. So that was one of the algebra tricks that we addressed in the previous lesson. If you see addition or subtraction in the numerator, it has to be in the numerator. If you have addition or subtraction in the denominator, you can't do anything with that. But if you have addition or subtraction in the numerator, we can split this fraction. I think I'm going to take that route. So we split the fraction up. We get sine theta over sine theta plus tan theta over sine theta. So the front is equal to 1. The back, well, we can't cancel anything there. So let's change tangent into, whoops, not equals. Change tangent into sine over cosine. And then leave the sine of theta in the bottom. So that's 2a. So I changed tangent in the numerator into this guy. I left the denominator alone. Just to make sure that we're doing it right, I'm going to put that sine of theta in the bottom over 1. I'm going to take him. I'm going to flip him up and multiply. Yes, stuff is going to cancel, but you need to get the right result at the end. So 1 plus numerator is sine over cosine. Denominator flipped is 1 over sine. The sines do cancel. You get 1 plus 1 over cosine. It's important the cosine stays in the bottom. And then the goal is to get to a secant at the end of this process, and 1 over cosine using 1d is the same as secant. There you go. Weird looking smiley. Next one. So more fractions. We've seen quite a bit more of fractions today than we did in the previous lesson. I'm going to start with the left-hand side. Secant theta over sine theta minus sine theta over cosine theta. So options I see here, we've got sine and cosine already. We've got a secant there, which we can change using a reciprocal identity. Oh my gosh, keep yawning. So we can change the secant using a reciprocal identity. The other option, which is the option that I think I'm going to take, I see two fractions subtracted. I'm going to combine those fractions by getting a common denominator. So we've seen lots of different scenarios today where there's choices. So I just need to pick one. Again, if you pick a different choice and you work it out a little bit differently and you want to make sure that you did it right, take a picture and email it to me and I can check it for you. All right, so common denominator is just going to be the product of these, sine theta times cosine theta. And then when all you do is multiply the denominators together to get that common denominator, the shortcut is you're basically cross-multiplying to get the numerator. So the secant in the numerator of the first one gets multiplied by cosine, which is the second denominator. And then this has a minus in between. And then the sine of theta in the second numerator gets multiplied by the sine of theta in the first denominator, and you get a sine squared. So now I'm going to do the other thing that we could have done first. I'm going to change secant into 1 over cosine. So we could have done that first. I just opted to wait a step. And then everything else gets copied. The multiplication trumps the subtraction, so I want to multiply those together, but the cosines cancel. Make sure when you cancel those cosines, there's not a 0 left. There's a 1 left. And then the numerator is 3a. Numerator is cosine squared theta. Denominator comes along. And then now everything in this fraction is multiplication. We have multiplication in the numerator, we have multiplication in the denominator, and multiplication everywhere allows us to cancel. Cancel one of those cosines in the top with the cosine in the bottom. You get cosine of theta over sine of theta. The goal is cotangent of theta. And we are at that goal using 2b. we get cotangent theta. Oh, I'm running out of ideas. There you go. You get the beautiful one at the end or something. Okay, so here is your assignment. This one is also due by Sunday. And again, the name of the game is I can't fix when you don't try. If you don't try, you're not going to learn. I don't expect you to do them all right the first time because it ain't going to happen. But if you don't try and you don't write anything down, we are not going to make progress. So we have to try.